How high is the kite? It's already been set up for you. So let's, again, remember we're using SOHCAHTOA, and I hope you wrote that down somewhere on your page so you can remember which ones you're talking about. So in this example, we have our angle already given to us. 100 is which part? What is 100? It's the hypotenuse, right? Remember, hypotenuse is always across from the right angle. So this is my hypotenuse. X is the what? Opposite. Okay, so if I have hypotenuse and opposite, Dakota, what trig function am I going to use? What? Sine, right? So sine of the angle equals opposite over hypotenuse. I am still setting this up because this is still new to us, and I would like you to still set this up. Okay, now we're going to solve the problem like we have been doing. So instead of the angle, we're going to put in 52. The opposite side is x. The hypotenuse is 100. Now, are we before you begin using your calculator, are we solving for an angle here? No. So should we be using inverse function? No. Okay. So how do we solve this for x? What do I need to do? Good. Multiply 100 on each side because we're trying to get x by itself. And now I just need to do 100 times sine of 52.
78.8.
78.8. Can anyone echo that?
Yep.
A few of you? Okay. 78.8. So let's talk about, because this is a story problem, what do we need to do with our final answer? Write it in what? In a sentence. Okay, now, how high off the ground is the kite? That's how we're going to start. The kite is... Now, did we round 78.8? Was that rounded?
No.
It's just 78.8, period?
Well, 78.8. 78.80.
Okay. So we can say the kite is approximately 78.8 feet off the ground. The kite is approximately 78.8 feet off the ground. So all these story problems is taking what you just learned and putting it in a story problem. The math is not new here. Okay, the hardest part is going to be setting up the picture. Okay, so let's look at the next example. There is no picture here, right? Which means I need to draw a picture. From the top of a vertical cliff 40 meters high. Okay, so I'm going to draw a cliff. This is 40 meters. The angle of depression, which we haven't talked about yet, of an object that is level with the base of the cliff is 34. Okay, there's an object somewhere that is level with the base of the cliff. Base of the cliff is the bottom, right? So we're just going to put a little, whatever the object is over here. Remember, we're trying to create a right triangle every time. So let's go ahead and connect. Draw a right triangle. Something is 34 degrees. Is it this angle up here or is it this angle down here? That's the question that we have to figure out. Okay, so don't mark anything on yours yet. Let's talk about what this angle of depression means. That means if you were standing up here and you were looking down, okay, if you were standing up here and you were looking down, the angle that is parallel to the horizon, which is this one right here, this would be 34 degrees. That's great, except for that doesn't get me inside the triangle. Right? I'm not inside the triangle, I'm outside, and so now this doesn't help me at all. Except for, if you remember this, we have parallel lines here, right? If I am parallel to the horizon, what do you know about this angle here and this angle down here? What are those angles? Alternate interior. And what do you know about alternate interior? They're the same. So this angle down here is 34 degrees also. And this question says, how far is the object from the base of the cliff? So the base of the cliff is over here. And I want to know how far this is down here. So this is going to be my x value. So if I have the angle 34, what two pieces have I been given? What's the 40? Opposite, right? And so what's x? Is it hypotenuse or is it adjacent? It's adjacent, good. And opposite and adjacent uses what, Tracy? What do we use for opposite and adjacent? Got you with your mouth full, huh? It's okay. Opposite and adjacent uses? Good, tangent. Okay, so we're going to say tangent of our angle equals opposite over adjacent. (40 over x). How do we solve for x when it's in the denominator? Okay, Dakota's reminding us we need to flip these two. Do you guys remember that? Okay. So this is x equals 40 divided by tangent 34. Adela, what do you get? What'd you get? Okay, 40. Put in your calculator 40 divided by that little tangent button. 34. Enter. What? 59 point what? 59.3. Did anyone else get 59.3?
Yes.
Good. 59.3, and it's talking about the length of something. So 59.3 meters. So again, the sentence says how far is the object from the base of the cliff. So I'm going to say the object is 59.3. Is that what you said? Meters away from the cliff.
Something I don't get is why we don't put it on the bottom of 46, 34. Because what I read over here, I didn't.
36.
No, 34. Instead, x, why we don't put 34? Instead of
34 is the angle measurement, right? And the angle measurement always goes where the angle part is. Are you talking about in the diagram or in the problem? In the diagram? Because 34 is this angle right here, right? This down here, I don't know if that's 34 or not, but I know that my angle is 34, okay? All right, example 3, who wants the iPad? Not everyone at once. All right, Tish. Okay, let me get you scrolled down. Okay, an airplane takes off 200 yards in front of the 60-foot building. This one's already written for you, right? So this one's already written for you. You just can't put your hand on it. You gotta point at the end. All right, so 200 yards in front of a 60-foot building. At what angle of elevation? You also have an eraser then. That's all right. You can either hit undo or the eraser.
This undo.
Yep. There you go. Okay, assume the airplane flies in a straight line at the angle of elevation. So, again, let's talk about this a little bit. Here's our angle of elevation where the x is. Okay? So, what are these two sides? What's the 60?
The opposite.
Opposite. So, let's put an O there. Takes some getting used to. And then what's the 200?
Adjacent.
It's the adjacent, right? And so opposite and adjacent is from what, Austin?
Tangent.
Excellent. Okay, so opposite and adjacent is tangent. Go ahead, as Tish is filling it in, you fill it in as well. Okay, if x is our angle, Tish, what are you doing? If x is the angle, what are you doing here?
Inverse.
Inverse, right? Because inverse undoes the tangent, and if we want to get x by itself, remember when we're solving for an angle, we always have to do the inverse. And then you're going to write a complete sentence. So it says, at what angle of elevation must the plane take off in order to avoid crashing in the building? Boy, this is kind of actually applicable. If you've ever been on a plane, they don't just randomly choose an angle to take off at, right? Some of them are going to have to really crank that nose of the airplane off to make sure you miss that building or the flight control tower or whatever. All right, so is it yards?
No,
That's the question.
that's not
Should
good.
it be yards? Should be degrees, right? So
Yeah.
16.7 degrees. You can use a little eraser button. Tap it. Tap the eraser. There you go.
Oh.
There you go. And then you can erase your yards. There you go. And then tap your pencil button. Whichever color you want. 16.7 degrees. And I would say 0.7 degrees because that 0.7 of a degree could make or break whether the landing gear is going to come off when you hit the building, right?
So would it be 17? Round this up to your whole number?
What does it say? Does it say how to round it? It doesn't. You could say approximately 16.7, or you could say approximately 17 if you want to make sure you clear that building, right? Okay. Any questions about number 3? You all have a sentence, right? The plane should take off at an angle of 16.7 degrees. I want to see your sentences. The plane should take off at an angle of 16.7 degrees. Excellent. All right. Nice job. Okay, next page. Flip it over. A 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? All right, so we have a wall. So let's draw a wall. Bam, there's my wall. I know the wall is 13. Now, again, we talked about this before. If we put a ladder up against a house, do you put it straight up and down against the house?
No.
No, because you're going to fall off, right? Instead, we set the ladder at an angle. So we're going to set our ladder at an angle, and you can draw your little ladder marks if you want to, whatever. The ladder is 14. What? Yes. With pegs on the sides. What is the angle of elevation? Here's a hint. Whether it says angle of elevation or angle of depression, you need to hear this clearly. Whether it says angle of elevation or angle of depression, you are always talking about this angle down here. Always. Okay, so the angle down there in the bottom. That's the angle that we want to figure out. So I'm going to put an X there. Anybody else want the iPad? Ooh, you guys are... Here we go. Okay, so we know our right angle is here. Okay, you can't put your hand on it or else it'll pick up your hand. Okay? Okay, so label your size for me to put it. What is 13? Opposite. Okay? What is 14?
Hypotenuse.
Hypotenuse, okay? So what uses opposite and hypotenuse, Chelsea?
Sine or whatever.
Sine. Good. Okay? As Dakota's working it, I want you to work it as well. Sine of the angle equals what?
13.
Opposite over hypotenuse. Yep, good. But if we want to get rid of that sign, right? Inverse. Excellent. We want to get rid of sine, we need to do inverse. So you're looking, where's your variable? It's here, right? So we, okay, Dakota has 68.2. What do you have?
60.
68.2? All right.
Yeah, around
So
there,
is this
69.
measurement, what is this?
I have 68. I know, but I have rounded that thing up.
Okay, no, you don't need to round it.
Feet.
68.2 feet. Is it feet? What is the question? At what angle of elevation must the ladder be situated? So this is representing, 68.2 is representing the what? Degrees, the angle, right? So 68.2 degrees. So the ladder must be situated at 68.2 degrees. Write your sentence for me. The ladder must be situated or set. I'm going to use a big word. The ladder must be set at an angle of 68.2. Excellent. Okay, a person stands at the window of a building so that his eyes are 12.6 meters above the level of ground. All right, this is kind of an interesting question. So let's look at this one real quick. I'm going to move my screen down. A person stands at a window of a building. So we need to draw a window of a building. Okay, so draw a building with a window in it at the top, somewhere like that. Okay, so draw a building with a window at it. Let's draw it maybe, did I say at the top? Let's make it kind of near the bottom instead. Because we're only 12.6 meters away. I'll get out of your way. So I have a building. Whoops. Here's my window. The person's inside the building. Okay. From here to here is only 12.6. From the ground to the person's eyesight is only 12.6. An object on the ground 58.5 meters away from the building. Okay, so I have something that's over here that's 58.5 meters away. Compute the angle of depression of the person's line of sight to the object on the ground. So if it's their line of sight, wouldn't you agree they're looking down at it? Okay. And remember we said whether they're talking about angle of elevation or depression, we're still talking about this angle down here. So we'll call this one our X. Okay, who wants the iPad? Aaliyah? Great. You got it. All right, so let's label 12.6. What is 12.6?
Your opposite.
Opposite. Okay? Put a no there. What is our 58.5? Adjacent. Okay, so opposite and adjacent uses what, Patrick? Opposite and adjacent, we use what? Okay? Tangent. Perfect. Okay, so we're going to be using tangent of our angle. We'll call that angle X. Good. Aaliyah's setting up the problem for us. Tangent of the angle is opposite over adjacent.
Whoa. There we go.
Good. Okay. Excellent. How do we get X by itself? What do you have to do?
Numbers.
Okay.
So, I'll just go. Whoops. How do you
Eraser. You gotta tap it harder. There you go. And then tap your pencil again. Good.
So,
Please make sure yours is set up like hers. Excellent. Okay, now we're going to use our calculator.
so we got 12.2.
That'd be degrees. So put your little circle behind your two.
All right. 12.2. Anybody else get 12.2? 12.2. And this is degrees, right? It says. Are you ready? I like chicken. Oh my gosh. You spelled chicken.
It was actually cheese.
Oh.
That was close.
What is that angry face over there? Aaliyah, you don't get the board anymore.
That's the point.
No, it's not. Okay, then every day you're going to get it. All right. She likes cheese. I do too. Okay, 12.2 degrees. So The angle of depression is 12.2 degrees of a person's line of sight. Something like that. Okay, why don't you try to do number 6 on your own? A ramp is needed to allow vehicles to climb a 2-foot wall. The angle of elevation in order for vehicles safely to go up must be 30 degrees. Okay, so we don't know what x is, but we know that it needs to be less than 30 degrees. So if I'm looking at this problem here, what is 2? Austin, what's the 2 value? Opposite. Okay. What's the 5, Amanda? Ooh, be careful. We're across from the right angle, right? So we're the hypotenuse. What uses opposite and hypotenuse? Sine. Good. So we have the sine of our angle equals opposite over hypotenuse. Sine of x is 2 over 5. Okay, so how do I get x by itself? Patrick, how do we get x by itself here? He knows.
Inverse.
Good. Okay, we're going to take inverse of the sine. Is that what you're going to say, Chelsea?
Yeah.
Good. Good thing you guys are on the same wavelength. Sine of inverse. I'm sorry, inverse sine. What do you get when you put that into your calculator? 23.6. I've heard 2 people see 23.6. I need 3 more. 1, 2, 3. Excellent. 23.6 degrees. Now, let's look at what the question said. It said, can the ramp be used safely? Meaning, the angle of elevation must be 30 degrees or less. So, can this ramp be used safely? Yeah, because 23.6 is less than 30. Okay? So that's how we're going to answer the question. Not just the ramp is 23.6, but yes, the ramp can be used safely because, not BC, but because the angle is 23.6 degrees. Wow, my handwriting is horrible. Yes, the ramp can be used safely because the angle is 23.6 degrees. Okay, in your homework today, there are no pictures drawn. You have to draw all the pictures today. That's going to be the hardest part of this assignment, is drawing the pictures. Okay? There are a couple that are a little bit tricky, so I want to go over them with you. But this is what your assignment is just working these problems out. You already know how to do sine, cosine, tangent, just like we did in the beginning of class today. And so the second part of class is just taking what you know, and putting it to a diagram for a real-world application. All right?